We're not just designing a cooling system. We're designing a computer that happens to be the size of a building. And we can actually optimize across all of these engineering domains.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Since Google was founded in 1998, it has flipped the way that we interact with the world upside down in less than 3 decades. It is our season finale for Season 2, and we are going out with a bang. Not one, but 2 brilliant senior VPs of engineering from Google, both of whom are Google Fellows, join me today in the lobby. Luiz Barroso and Amin Vahdat are 2 engineers born from 2 very different beginnings who came to the United States to pursue academic excellence and have ended up helping Google change the world. Outside of their individual brilliance as technologists, engineers, and leaders, Luiz and Amin share an inspiring friendship, camaraderie, and brotherhood that has carried them through the many triumphs and trials they've faced at Google. We'll talk about how Google's mission statement has driven it to evolve towards hardware development, the vital role data centers play in its multi-billion-dollar future plans, and we'll talk about why so-called healthy hubris is sometimes the key to the next killer design. As a young child in Iran, Amin Vahdat caught his first glimpse at a computer when he was just 6 years old. For the young boy, it was love at first sight.
I was born in Iran, in Tehran, Iran. My family moved to the United States when I was 6 years old, but shortly before, I saw a magazine in a store highlighting this new thing called a computer. Well, I'd never seen a computer, but somehow I knew right then and there that I was going to become a computer programmer. Somehow I was very lucky. We had a computer lab in high school, a room full of 30 IBM PCs, and one IBM PC-AT, which at the time ran at 8 megahertz. It could compile, thousands of lines of code per minute. And I convinced my parents to drop me off at 6 a.m. every day. And I figured out how to break into the computer lab and basically get a couple of extra hours of programming in every day. The school eventually discovered me, and it was a different time. I guess I was lucky, where they just mostly laughed at me and said, "Oh, if you're going to break into the lab, here's the key. Why don't you just go in and turn on the lights and do your programming not so surreptitiously."
With an ever-growing dedication to computer programming, Amin set his sights on the only conceivable college degree for him: computer science. There was just one problem.
Going to college, the one argument that my parents and I had actually prior to that was what I would study. Was it computer science or electrical engineering? I was dead set on computer science. Of course, I decided when I was 6 I was going to be a computer programmer. They said, no, absolutely not. My parents hadn't been to university. They didn't graduate from college. But in Iran, and I would say in the Middle East, electrical engineering was a big deal. Engineer was a title in Iran, like doctor. Like you were referred to as, let's say, engineer Barroso, if you were walking along the streets and someone introduced you. Computer science, what is that? Programming computers, who wants, there's no future in that. So they won the argument, and I wound up majoring in electrical engineering as an undergrad. To my, at the time, resentment, but it was the best thing that ever happened to me, actually, because I had to take 2 years of physics, 2 years of advanced mathematics. The fundamentals that I learned at the time have been invaluable throughout my career. I did wind up switching to computer science for graduate school. My parents finally weren't able to win that side of the argument, but my path was somehow this spoke to me, and somehow I was fortunate enough where it was something that I loved doing. Actually, absolutely just loved doing from an early age.
Amin's undergraduate work in electrical engineering, burdensome as it may have felt at the time, would prove invaluable later in his career, first as an academic, then as a software engineer, and ultimately now as a senior vice president of engineering at Google and a Google Fellow, whose teams solve system-wide technical challenges.
In computer science, there are many more theoretical aspects to study. And of course, I have great respect and appreciation for it. But the thing that always drew me was the systems aspect of it. All right. And in the end, efficiency, power efficiency, performance efficiency, you can't go after any of that without understanding what the hardware fundamentals look like.
And there it is. Listeners of this podcast, rejoice. Even in computer science, even at companies like Google, hardware fundamentals are an essential foundation for your body of work. And that's where Luiz Barroso enters the picture. Louise is also a senior vice president of engineering and also a fellow at Google. Luiz's story begins in Brazil, where he was born into a family of physicians and raised by a man who would be among his greatest influences.
My grandfather was a surgeon, and my father became a surgeon. My uncle is a gastroenterologist. My aunt is a psychiatrist. And then the next generation, I think nobody else went into medicine. But I think the connection with my dad, so my father was, of course, like for many of us, a really, pivotal person in my life, a workaholic, and somebody who always worked on public hospitals in Rio de Janeiro, never actually held an academic position, but he was always studying things. He was always trying to figure out how to make things better and documenting them and, following sort of experimental scientific method from the position of a practitioner. And he ended up having actually a very sizable publication record. And I don't know if intentionally or not, but my career ended up going somewhat in that direction, in that I started as a researcher in industrial research labs at Digital Equipment, and found my niche or my comfort zone mainly as an engineer who happens to, as a hobby, do some publishing, if you will. Because I always tended to have the luxury of not having to publish to be promoted. I was not in the research lab at Google. I had the luxury of only publishing when there was something really cool to talk about. And generally, those were in the past tense, right? As opposed to kind of academic research where you have an idea, you publish it as quickly as possible because somebody else is going to one-up you and have that idea before you.
Right.
I love the kinds of papers that are experience papers, that are about, hey, it's not just we had this idea. We spent 4 years building this enormous system based on this idea. And this paper is about whether it worked or not in practice.
Yes.
Right?
Yes.
So that practitioner angle, I think, is the thing that I certainly share with my father. And I don't think I was ever conscious of that. It was just in retrospect that I realized that in very different fields, we ended up having kind of a similar approach to academic inquiry.
So, how did Louise end up at Google? Well, it was an abandoned microprocessor design project at his then employer, Digital Equipment, that precipitated Louise's move to Google, and not as a hardware engineer.
At Digital Equipment, we were working on what was going to be the first multi-core processor in the world back in the late 90s. Lots of relatively wimpy cores performing better than one very fast core was the idea driving this project. And a few months before our chip was to tape out, Compaq, that had acquired Digital at the time, decided, we're going to get out of the microprocessor business. So we had to work for years on that chip, and that chip never saw the light of day. We published a couple of papers, and it ended up being on the research side, well-cited piece of work. But boy,
Yeah, that's a lot of time in your life that you can't get back.
That's right. Yeah. So I had a couple of colleagues from Digital that had come to Google, and in particular Jeff Dean, who really wanted me to come to Google. That's late 2000, early 2001, and I was telling him, "You're insane. I don't know anything about web services or search or information retrieval or any of those things."
Right.
But, I knew a lot about performance optimization. I could program. And at some point, I decided, what the heck, I'm going to make a career change. And I'm going to try to learn how to be a software engineer. And went to Google, not to build hardware at all, but to learn to be a software engineer. And for the first 3 years I was there, I did that, thanks to Sanjay Gemawat and Jeff Dean and others who really taught me how to be a programmer. And it was only 3 years into my tenure that Urs Hutzler decided, you know what, we need to get a little bit more serious about building hardware and building data centers. And they looked around. I was the closest thing to a hardware person in the company at the time. And
I have this mental picture of 100 software engineers being told somebody needs to volunteer to take the hardware lead, and 99 of them stepping back one step. Louise looking around and saying, well, what?
And so I went back, and then with Urs, we started the platforms team that eventually became, the team that designed our servers, our data centers, our networking systems.
And this is where the stories of two engineers born 7,400 miles apart, one to a family of physicians, the other to parents who themselves hadn't completed college, converge, leading to a truly unique partnership between two engineers set against the backdrop of one of the most well-known companies on the planet.
The superset of that team is actually led by Amin today.
Hi, I'm Kate Smith. I'm the editor-in-chief of All About Circuits, and I'm here with Brandon Becker of Rome to talk about silicon carbide. Thank you so much for joining me, Brandon.
Thank you so much for having me, Kate. I'm so excited to talk to you and so excited to share an update about Rome Semiconductor.
We're seeing massive continued growth when it comes to cloud computing and data gathering, especially as 5G adoption picks up. So how does Rome approach these megatrends?
We see these trends really in two areas. And the first area is in the data centers and in the infrastructure themselves, so higher power, but as well as the backup systems.
So what challenges is Rome tackling for silicon carbide for power systems in large-scale data centers in particular?
Rome is really focused on two areas. And the first one is the technology. So we're continuing to come out with new technology to allow these trends to continue. And the other is capacity. Since there is a global shortage of parts, we are investing to ensure that there's not going to be a shortage.
Where is Rome going next to make silicon carbide even more useful for engineers who are designing power supplies?
We are releasing our 4th generation trench-stick MOSFET at the end of the year. The performance is best in class as we're reducing conduction losses and switching losses.
For more information, you can speak with an expert about Rome's silicon carbide portfolio at romesemiconductor.com.
Thanks so much.
All right, we're back with a wonderful story of two amazing engineers whose paths collided just in time to make Google the company that we all know and rely on today. Amin, from a childhood that was split between your home country of Iran and then later the United States, you ended up a professor in computer science, mentoring countless future problem solvers and fellow engineers, to then be recruited heavily by Google. And when I say heavily, I mean with the determination of Sherman marching on Atlanta, because you were also being recruited by a different tech company, which shall remain nameless. So when you're weighing, do I leave academia and go to this company or that company? And they're both huge. It's very exciting. How do you make that call without any prior frame of reference?
In the end, the selling point was come to Google, work with the brightest people, and help us define what the next issue is. In other words, you could go to some other place and teach them what you already know. Or you can come here and work with some amazing people to define the next frontier. And for me, that was irresistible. And I was very fortunate in that Louise had recently made a move within Google to what's called the platforms team as the senior technical lead for essentially the entire platforms organization. So for me, I was also moving to the platforms team as a much more junior engineer, of course, but the chance to work with him and others in the team to figure out what's on the horizon was just irresistible.
We recruited Amin probably as heavily as we recruited anybody during my days at Google. We were very close to losing him. Amin had actually a much longer and celebrated career as a full professor of computer science at that time at UC San Diego. But somehow he decided he wanted to explore industry.
Okay.
And he was very close to joining, one other big tech company. And from that point on, Urs Hutzler, myself, and many others said, no, we're going to have this guy.
But now, you're right. Now, meanwhile, as you're recruiting Amin, Google is getting more and more serious, as you mentioned, about designing custom hardware infrastructure. So, even though data centers per se weren't exactly the company's primary business focus.
So when I arrived at the company, they were actually already in that direction. Larry Page was already kind of building disk arrays out of Legos, right? And trying to use inexpensive components to build very powerful systems. We have a bunch of people from Urs Hutzler's compiler team at UC Santa Barbara that came to Google. That, again, a bunch of programmers didn't know anything about hardware. That didn't stop them at all from just deciding, we think we can do this better than all these companies that are building servers, right? So there was already a DNA of, you know what, we can be nimbler, we can do better, we can use inexpensive components and put them together in ways that can actually create amazing things. Rather amateurishly so in many cases. If you see some of our earlier racks, there's the infamous cork board. It's just, slapped together with boards on top of each other and cork and fans attached. We certainly needed to do a little bit better in that regard, but that DNA was already there of questioning the way computer infrastructure should be built, and in particular, large-scale computer infrastructure should be built.
What did large-scale computing infrastructure at the enterprise level look like in the early 2000s compared to, say, our modern data centers today?
Boy, unrecognizable from what we have today. A data center back in the day looked like a collection of broom closets. Basically, instead of walls, they had grate and doors around them. It was the result of a combination of engineering traits trying to do something without necessarily talking to each other. So They were basically third-party colo facilities, right? A company like Google didn't own a data center. We rented space on businesses that still exist today where you can go put your servers on. I think this is, cloud computing is actually overtaking that. But back in the day, that was the norm, and Google did that as well.
Sure.
So, you go and they give you a cage and a power cable and hopefully a little bit of cooling and some networking uplink and, go, right?
Wow.
There's pictures of these early days, I think, with Louise, where the cooling was literally a fan from Fry's, hopefully 24-inch fan from Fry's.
It was a big, one of these big floor fans. One of the things that those colos didn't realize at the time, they didn't get their model right. They weren't charging us for power. They're charging us for space. So we basically gamed that system. We crammed the ridiculous amount of equipment into the space they gave us.
Yes.
And of course, there wasn't enough cooling for it. So we would go to Fry's and buy these floor fans and, essentially steal air from other cages next to us to blow cold air into our servers so that we wouldn't overheat. It was primitive. And of course, networking connectivity was, it's difficult to imagine. It was only 20 years ago. But the way we created a copy of our index back in the day to a different data center so that we had redundancy was to basically unplug a bunch of disks, put them in the back of a hatchback car, drive it to the other data center, and then plug those disks in the other data center. That's how we made copies of our index back in the day.
This is only 20 years ago.
Yeah.
Road trips. These were the weekend road trips for the engineering staff, actually, from what I heard.
That's right. The transporting disk drives on the back of a hatchback car on 101 freeway was faster than the internet at the time.
But Dave, actually note that even today, the highest bandwidth you can probably get is putting storage into 747 and flying it. That's tough to beat, actually.
Yeah, that's a good pipeline if you can secure one.
Yeah.
I will say things have improved because a couple days ago I found out that plugin on my WordPress website displayed all of my personal contact information if you Googled my name. And I panicked, removed the thing. I went on my Google Search Console. I typed in the URL and said, remove from your cache, remove from your index. And 12 hours later, this problem is resolved. So I'm assuming nowadays you don't have Amin throwing stuff into the back of his, Nissan and flooring it down the 101.
Well, actually, I was going to say maybe some people actually jumped in the car and put the discs in. Dave's request has come in, and we better go replicate cross country. No.
Oh, Dave Finch has contacted us. Everybody scramble. Was it true that Google was also at some point in the first several years that Google was becoming Google, you would find data centers in shipping containers?
Yeah.
Oh my gosh. So I think of things like heat and security. Like you don't want somebody being able to come in and physically move things around or rain getting in, but a shipping container seems to be quite antithetical to what you would want in a data center.
I confess it's a little bit crazy. Yeah, that was our first custom designed data center. The first time we built a data center ourselves, we decided that it was a time where it was very difficult to get a new data center space built. So we felt that it was really important to optimize for speed of deployment. And speed of deployment, right, if you're in manufacturing, benefits from prefabrication. So you can think of a container full of 1,000 servers as a prefabricated, data center room. And that was one of the main appeals of it, in that we could actually much more efficiently build these things in one place than ship it somewhere else. And the data center was already all wired up already, instead of having need to locally sort of plug and assemble everything in place like it was traditionally done. So that was one of the motivations. Another of the motivations was a shipping container actually is a very good environment to reduce the airflow plenum, so that you actually save energy in cooling, because it's a very contained space. You can have blowers on the floor of the container blowing air. Imagine that the servers actually are on the two walls of the container, the two long walls facing in.
Yeah.
The air comes out of these blowers, goes through the server towards the side walls of the container, gets sucked down through this hot plenum, then goes through heat exchangers, and then come back as cool air again. And this entire air loop is basically 10 feet. And it's very inefficient to blow air at very long distances, like it is in a very, very big computer room. So there was a few characteristics of the data center that actually improved cooling efficiency quite a bit. Now, having said that, we built a 44 container data center in Atlanta as a first proof of concept.
44.
It was really a remarkable piece of engineering. I mean, you have to have these contraptions to actually pick the container at the end of the building, lift it up, and then sort of carry it in the air, and then rotate it, and then put it in place so that you could connect with the networking spine of the system. It was quite elaborate.
This seems very, very creative. Like, do you think what was working in your advantage was you hadn't designed data centers for 30 years?
We're unencumbered by expertise. Yeah. So that certainly was working for us. And
I want that printed on a t-shirt, unencumbered by expertise.
What happened at that time is that, I think I alluded to that earlier, no one ever really tried to build a data center with a holistic view, end to end, from building the shell, to power distribution, to cooling, to hardware design, to software design, networking, storage. And when we began to look at it as this is a computer as opposed to a bag of machines or of collections of machines,
right,
the opportunities for optimizations were actually quite obvious. So we were lucky in the sense that we were probably the first group of people who said, we're not just designing a cooling system, we're designing a computer that happens to be the size of a building. And we can actually optimize across all of these engineering domains. And that was, I think, if anything, the main vector of innovation we had.
as managing this volume of data and processing this volume of data and doing it reliably and quickly and faster than your competitors, as this has grown up in our lifetimes, you're solving the problems that no other generation has ever solved before. And that's remarkable in and of itself. But it also occurs to me that the first wave is we need to handle and manage and sort a vast amount of data. We need a lot of servers. So now we need square footage to place the servers. Oh, now we have to cool down the servers. Oh, maybe it'd be more efficient if the stuff actually talked to each other as a system instead of gluing together a bunch of spare parts that we had lying around. Okay. So there's that part of the evolution. And now we're starting to get into our data centers consume so much power that it behooves us now to even look at the power electronics that are, powering our data centers and how we're delivering power in that way. So that might be one of the eras that we're moving into now in terms of data center. What are some of the other major evolutions that you're seeing that have to happen in order for companies like Google to be able to operate in this way?
We were probably the first people that understood the importance of energy efficiency, because it turns out that our hardware was so cheap that we were the first ones to look at our overall cost of ownership and cost of operation and see, hey, wait a second, the power bill is kind of high, right?
Yeah.
Because compared to, we were so good at building kind of inexpensive hardware that it showed. So very early on, from an electromechanical standpoint, from a hardware design standpoint, even from a software design standpoint, not me, but our team had significant innovations in this area, right? Our first generation of data centers reduced the amount of energy waste by energy transmission losses or inefficient cooling by sort of at least a factor of like 4 from the best data centers that were there at the time. Mm-hmm. And in some cases, a factor of 10, if you really looked at the average colocation facility. And there are innovations in a bunch of other areas, right? We worked on understanding the power usage dynamics of data centers and derived insights into what chip designers should do to make data centers more efficient as opposed to sort of cell phones. Right? Cell phone is a very different machine from a data center. And energy proportionality was actually one of these insights that ended up impacting the industry in the sense that energy proportionality is pretty, it's a pretty obvious thing, right? If a computer is being used only to 10% of its capacity, you shouldn't be using like 90% of its power, right? You should be using kind of 10% of its peak power, right?
Sure, yes.
But we're the first ones to understand that actually that was really important for server class systems and data centers. And that improved energy efficiency actually quite significantly once we actually got the industry to come on board and begin optimizing their designs for it. Now, Amin is managing this area these days. He could tell us sort of more about what the challenges are today and what we're looking at this moving forward.
Absolutely, and I'd refer the audience actually to a really amazing book that Louise and Urs published a few months before I joined Google. They published it in 2009. It's called The Data Center as a Computer, an Introduction to the Design of Warehouse Scale Machines. And it really set the framework for thinking in so many different spaces.
Amazing.
By the way, the book is free. This is an open source text. But 20 years ago when Louise joined Google, the thought of having tens of thousands of servers in a warehouse, from power to racks to compute to storage, acting on individual problems, was unthinkable, right? With sort of commodity off-the-shelf processors, with commodity off-the-shelf operating systems. This is not how computing was done 20 years ago at all. And I think that unencumbered by expertise is one way to put it. A healthy disregard for the impossible is another quote I'll share with you from Louise. And I think that could be on the back of the t-shirt, Dave, that you print. And I think maybe Louise and I will have to talk afterwards about getting some of these t-shirts printed, because I think it would be
out there. Dave, you need some merch. We can provide you some merch.
Yeah.
I love it.
I'd wear that T-shirt actually quite happily.
And by the way,
the
that
point
quote
here
is not
is,
mine. I think Larry Page heard that quote from somebody and made it a mantra for us. Yeah.
I love it. You could tattoo that on your forearm. It's brilliant.
Yeah, but so I think that this has been a fairly monumental shift, and a lot of these things are driven by metrics. Louise talked about energy proportionality. I think that Google, led by Louise and others, defined the notion of power usage efficiency, PUE, and we basically were able to show that of the amount of power coming into a data center, what fraction actually gets used for computing, and that ratio was shockingly low. Like Louise mentioned this, it could be as little as 25% of the power delivered or less was actually used for the computing. Just lots of waste through the electrical systems, etc. And other things. We also were among the first to look at, okay, what a fraction of the power is coming from clean sources of energy. And I won't go into the numbers, but we're on record with respect to what our current values are and what our goals are in terms of renewable sources of energy to power all of our data centers across the world, frankly. And this remains a substantial challenge for us as we've really driven down this PUE close to 1.0, meaning that essentially almost 100% of the power that comes into one of our facilities now is actually being used for compute. And then Louise mentioned energy proportionality. Well, if the server only needs to do 10% of its max capacity, hopefully it's using somewhere close to 10% of max power. We have more work to do there, but we've made a lot of progress. Today, I think we're on the precipice of a whole new set of challenges that we have to go after, basically, and this is really driven by fundamental trends in the industry with respect to Moore's Law and the end of Denner scaling. What we're seeing right now is essentially a place where general purpose compute in a one-size-fits-all model isn't going to work for the industry as a whole any longer. So in the heyday, early 2000s, let's say, to some extent into 2010 and beyond, we were in an amazing place, essentially, where you could wait 18 months, buy the latest, greatest server or the latest, greatest chip from your favorite vendor, and your code almost magically would get twice as fast. Mm-hmm. Exaggerating a little bit, but to some extent, this was true. And when it ended, we were able to go to parallelism, where your code wouldn't get twice as fast magically, but you got twice the compute power in the same server. Right. And you'd have to figure out how to parallelize your code to take advantage of that. We're in a place now where both those trends are slowing or stopping. So what we're seeing is the rise of domain-specific accelerators, really taking some substantial fraction of our general purpose compute over in the data center. We're on record with a couple of examples of this to really good effect at Google, one for machine learning and one for video processing. And the idea here is essentially if we build infrastructure at scale that is customized for a single application, let's say machine learning. And the idea here is Google and others delivering real-time translation services for language. Mm-hmm. Could be text-based, could be actually audio-based. The amount of really application-specific work that has to happen in response to you speaking to Google Assistant or equivalent, asking it for something, it recognizing what you're asking for, getting you the information, there's just an enormous amount of compute, general purpose compute that would be required, power that would be required to support Google's user base for this. The observation is by building infrastructure specialized for this task, we can be, let's say, as an example, an order of magnitude more efficient, both performance efficient, but as critically, power efficient. So what I love about the kinds of work that we do is it's not just about making things 5% cheaper, 10% cheaper, 50% cheaper. Like that's cool too, by the way. We'll take that. But it's really about, here is a really compelling use case. Real-time.
And how do we make it work?
And how do we make it possible? This is the healthy regard for the impossible portion of it. That what I love about being at Google is that we have a number of examples of enabling use cases, application use cases, not software requirements per se, because the software requirements are driven by the goal of delivering these services that wouldn't have been possible without the underlying infrastructure breakthroughs. And we're at a place now where, I grew up watching reruns of Star Trek, and the universal translator, real-time universal translation, was science fiction when I was growing up. And it's far from unimaginable today. And, I won't predict when, but I will boldly predict that we will have available, not necessarily Google. I won't make any product predictions, but society will have universal translation capability at some point in the not too distant future. So making science fiction, that's what life is like, is one of the really fun parts, I would say, about being at Google.
Hey, it's Dave. This episode is sponsored by EBV. Techies watch out. EBV's new podcast called Passion for Technology is dedicated to the latest technologies, trends, and applications in the electronics industry. Listen to their podcast episodes about silicon carbide and gallium nitride, wearables, or robotics. Only a small part of the episodes are already available now. More are on the way. To make sure you don't miss an episode, follow EBV's podcast Passion for Technology on your favorite platform. And if you like it, they're always happy about a positive rating. So tune in and dive into the world of semiconductors. All right, we're back with Luiz Barroso and Amin Vahdat from Google. Just a mind-blowing conversation here about the evolution of the data center and how specialized hardware is really the unsung hero of this massive software company called Google. Now, guys, speaking of specialized hardware, with the post-COVID demands of digital media, specifically video, and as you mentioned, earlier, real-time language translation, these aren't typically you won't find these algorithms running super efficiently on commodity hardware, right? And yet, they're integral to Google's mission. So is Google also becoming like a chip maker right before our very eyes?
It's a good question. I'd say it's a little bit of a complicated answer. In the end, I think that we really are driven by our mission. And I do want to go back to it because I'm personally inspired by it. And that's to organize the world's information and make it universally accessible and useful. Now, what we find is that our needs, and maybe more to the point, our realization of our needs sometimes are ahead of the rest of the hardware industry. So in other words, we sometimes can't buy what we need.
Yes, right.
But with things like TPUs, with things like video encoding, and with other situations, we find that our needs and our need to integrate these things with our software stack, leveraging vertical integration, are such that it would be hard for us to either buy it that didn't exist. One could argue that a lot of the explosion that we're seeing in terms of startups around machine learning partially came from some of the announcements that we've made. And frankly, we published fairly extensively. We talked about publication early on, but we do believe in giving back to the community. And we have multiple papers on TPUs going into the low levels of their design. But the point is, prior to us going down this path, it didn't exist.
Yeah.
And it really was something that we had to do. So are we a chip design powerhouse? I like to think that we do pretty well. But it's not the first thing that we go to in terms of, hey, I need to think of a new chip to design, or we're not a hardware company, we're not a chip company. We're a company driven by our mission, which is to, again, serve our users with services. Sometimes the only way to do it is to build the hardware ourselves. But we often see it as a temporary state, a 1-year thing, a 2-year thing, a 3-year thing, maybe a 5-year thing. Sometimes it's a 10 or 20-year thing. But the point is, we believe ourselves to be part of a larger industry ecosystem. And from my perspective, I'd rather buy than build whenever possible.
I think this is an important point, right? If you look at Google's DNA, when we began the TPU program, it was quite, what is the right word? Sacrilegious, if you will, for our own company culture. Right, we, and particularly me, I didn't want to have anything to do with chip design anymore from my previous experiences. So we really resisted having to actually build silicon ourselves. And we actually had a really good track record of close relationships with the major chip providers. Really great, tight partnerships in which we could communicate to them our needs and And they will actually, in many cases, respond to that. And it was good for them, it was good for us, it was fantastic, right? So I think we maintain a little bit of that mentality, as Amin was saying, right? We're trying to solve a problem. We will build sort of specialized, or we'll build our own chips for those if everything else kind of fails, sort of, right? And I think that because we are a company with so many great systems engineers, like, Amin is a quintessential systems builder, right? The great thing about having people like that in our company is that keeps the hardware folks honest. Right? It's very easy for a company that really sees itself as a hardware company to want to solve everything by building new hardware. And having great software engineers around that can say, wait a second, I can actually change my code here. I can change the communication pattern there. And it turns out I don't need to change hardware at all. I'm going to give you a very brief example. I think this may predate Amin's tenure. We had some real problems with congestion in our internal data center network at Google. We're using some switches that have very little buffering, right? And when you do a web search, right, one query comes from a user, and it ends up sending messages or remote procedure calls to like 2,000 to 3,000 machines in a data center. So one message becomes 3,000 messages. And you can imagine when that happens, distributing those messages may overwhelm those switches, right? So if you're a hardware company, what do you do? Oh, you build switching chips with more buffering, right? That's what you do, because that's the only hammer you have. We looked at it and we solved that problem in 2 weeks by basically saying, oh, this is actually not a network capacity problem, it's a burstiness problem. The problem is that all these messages are going at the same time. So it made small software changes that actually orchestrated and created a little bit of noise in how these messages were being sent so that they would not be so bursty. And packet loss disappeared. And instead of waiting 2 years to design a chip with sort of more buffering, in 2 weeks, we had the problem solved.
It's one thing when you are 15 years ago saying, oh, geez, one message actually generates 3,000 hitting at the same time. Let's distribute them. And instead of a step function, now we have more of a curve and we can manage that's better. It's another thing when a company comes along and says, hey, we've invented a new type of cryptocurrency, and this is going to usurp every available bandwidth that we have in our data centers. As the folks at Google who are left holding this bag on behalf of the planet and the world of people on it, do you say, oh, come on, like we weren't supposed to be solving this massive problem. We were trying to go off in this direction, or is it just another day at work?
Well, I don't know that either Amin and I can speak to the socioeconomic sort of importance of cryptocurrencies. I would speak for myself by just saying the moment I saw the first set of these, I was just hoping that it would go nowhere, because it was pretty clear that if it became successful, it would dwarf the amount of energy used by every major tech company, right?
Yes.
So I'm actually quite concerned about this. I think we have a real problem there in that sort of general industry. I'm not close to that industry at all, but it's a little bit disheartening for me to see, Amin and myself and many others at Google, have, made a career out of making things, more efficient to deliver really helpful things for the world, right?
Yes.
So, to some extent, I think Google should be measured by, in terms in among many dimensions, but one of them is that how much helpful we are per, ounce of greenhouse gas we emit, right?
Yes.
And if we measure Google by this, and we measure how much benefit cryptocurrencies bring to society by the same metric, a few orders of magnitude difference there, right? So anyway, that's not my area of expertise, but it's something that I find very troubling.
I agree with Louise. I mean, what I'll say is that probably one of the things that Louise and I share, but I would say multiple people. It's part of the culture at Google, and part of I think what makes many of us happy to be at Google is that we're driven by a positive societal impact.
Yeah.
In other words, it is this usefulness test of the services that we build that really inspires us. And so I would say I haven't had a use case in terms of, hey, we have to scale up to do this, where I've thought, why would we want to support this? It's always been, wow, that seems like a really compelling thing to go after. And if we can just make speech recognition 10 times more power efficient, we can do it. Okay, let's figure out how to make it 10 times more efficient. Louise shared the story about growing up surrounded by surgeons. I've started my PhD wanting to cure cancer. That's how naive I was. And I didn't, come close, and never will. But the point is that I think many of us are in it for, hey, can we leave a more positive mark?
That's right. And by the way, you can rest assured that cancer won't be cured without the ability to process data efficiently. So,
right, and we have lots of great examples on the machine learning side, where, for example, we're able to potentially do the analysis and recognition of issues ahead of even world experts. And I do see that as a major opportunity for us in the years ahead. Still a lot of work to do there.
You're both speaking in such laudatory, complimentary, and appreciative terms of each other. You clearly appreciate each other. Is this a friendship that you have found in each other that started as mutual admiration among colleagues? How has your relationship grown, and what do you two mean to each other personally, professionally, as you've been, well, we'll just say in a sentence, transforming the world?
Well, I'd like to start just by saying that there are very few times where we feel like we have an opportunity to land somebody like Amin, right, at Google. He was a part of a relatively rarefied set of academics that was really interested in solving systems problems. He was not clearly optimizing, I think, for necessarily the other things that academics probably should optimize for. And at the time at Google, we had began innovations in data center networking that we're very proud of. And we looked around, and suddenly Amin was publishing papers in the general area and going towards the same ideas. And of course, I don't think we had met personally, but I, of course, knew of him. I mean, Amin was, in the WebOS, team at UC Berkeley back in the day, right? That was beginning to sort of look at, the infrastructure for the internet, what it is today. So, I mean, his pedigree was just astounding, right?
Wow. And it must have been astounding because this was before the area where you could Google him. No pun intended. Like to find an Amin, it had to be somebody who was doing that caliber of work that he could be found.
I know, right? But then, I actually met the guy, right? And, one of the things that I think it's remarkable at Google is that, we have people like Amin in that, he's at the top of our field as a researcher. He is an amazing manager of a very large team. He's a leader of a key area for us at Google. And he is somebody that, not just me, but anytime we see, I have a meeting with Amin in my calendar today, it's going to be a good day,
Yeah.
So there's a degree of warmth and genuine caring for people, right? That sometimes the caricature of a brilliant technologist. I mean, Amin is the CICOM Award winner in 2020. I mean, he's a big deal, right? And there's this caricature that people in our field that are very successful are abrasive or and somehow unpleasant to be with. And boy, we have an unfair share of people who are counterexamples to that. And Amin is at the top of our list. I mean, we are, we developed a close friendship We cry on each other's shoulders. We help each other. We have a meeting sort of later today where we're working together still on our hardware roadmap for machine learning. And it just is it's a real joy to have people of this caliber, both from a leadership, from a technical standpoint, and just as human beings, right? So, boy, that's certainly what keeps me here 20 years after joining.
Yes.
Louise is, as always, being too kind. I mean, what I can share with you, but a lot of accuracy in terms of friendship. I have taken just huge amounts of inspiration from Louise over the years. I can tell you that I wouldn't have made it through my first few years at Google if it weren't for Louise. I can just say that straight up.
Wow.
Louise talked about kindness. I've grown much more kind over the past decade as a result of emulating Louise. I'm not actually making this up. In other words, I'm the kind of person who needs examples, who needs people to emulate. And Louise has set an incredible bar. And someone where, I think it's fair to say 10 years ago, I ran hotter than I do today. Louise would be the first person I'd go to. And he would, somehow I'd be so upset, so mad, so ready to go yell at somebody. And after 5 minutes with Louise, somehow I'm calm, my blood pressure is back down, heart rate's, and the world, I was wrong. Wait a second, how could I have been so wrong? And after 5 minutes, I'm now, that kind of adjustment. Not to mention the technical side, where he would oftentimes, again, in areas where I thought I knew something and I thought I was the expert, I could go to Louise multiple times a week for feedback and learning. That to me was just awesome. So I would say that Louise has been a deep mentor, but someone who I've really looked up to and looked to emulate. And I think, I won't say late in life, in the middle of your life, it's, for me anyways, somewhat rare to find somebody who you just connect with that deeply. Like when you were 8 years old, it happened every day. Like, hey, everybody's your friend, and you connect with. When you're not 8, it's a little bit harder for me anyway, being a bit of an introvert. But Louise was someone who, again, I felt like just so noble, so kind, so brilliant, and so generous. And things that I seek to emulate with some. I would say I'm better than 10 years ago as a result. I'm not quite to the bar that Louise sets.
Well, I can tell you one thing about Amin is that he may say that he runs a little bit less hot today, but one of the things that I think he strikes a great balance at is that he remains really irritated about anything that's not perfect just yet. If it's not perfect yet, I mean, he stays awake at night, right? So he has maybe he's managed to mellow it a little bit, but he hasn't lost that constant irritation with things that are not perfect, which I think is fantastic.
I love it. That blue flame will always burn that hot. It sounds like to me what it sounds like is the fire isn't spreading as far when gasoline is poured on it.
I can control it. I can modulate it a bit better than I used to be able to. But Louise is absolutely right. I'm as annoyed as ever.
Well, that's why Google is what it is. If you weren't annoyed by things that were imperfect, you would get nowhere, A. And B, even if you have the greatest solution, the greatest technology, the most money, and the most and the best, we'll say, team of individual contributors, if you're a dysfunctional family, all of those resources go to waste. It occurs to me that the amount of respect and trust and this clear mutual support you two have shown for each other, this has to give a huge amount of confidence to both your leaders and the organizations, the people looking up to you. If you can emulate this working dynamic where you're just showing up for each other and showing up for yourselves in this way, I think the workplace is a great place to be most times. So let's do a quick lightning round, or ESD round. I apologize. ESD round. We'll start with something simple, and the answers will go, just because it's the order of the screens I'm looking at, the answers will go Luis, Amin, and then I'll ask the next question.
Great.
Okay. Sushi or steak?
Steak.
Sushi.
I love it. All right. American football or real football?
Oh, God. Real football. Come on.
This one could go on for a long time, but I'll give the actual answer. American football.
I like this. See, this is diversity of thought, another hallmark of a healthy organization. The third and final question in our lightning round. See, we've covered the most pressing issues of the day, sushi, steak, football. We covered food, we covered sports. And so now it's time for that third goofy throwaway question I always like to ask. And this one is, please describe, each of you, Amdahl's law.
Amdahl's law basically tells you that if you don't have perfect parallelism in a particular system, it doesn't matter in the way you structure the computation. It doesn't matter how much more processing power you throw at it. You will get no more performance improvements, no more speed up.
Yeah, I think it's a great answer. The analogy I would use is if you're doing laundry and you have a washer, a dryer, and you're the single person who can fold. Let's say you've got just an infinite amount of laundry. So you buy an infinite amount of washers and dryers to just run those things in parallel. You will bottleneck on your folding ability in the end. And it doesn't matter how many washers and dryers you have spinning through those clothes, you're going to start piling up a mountain of clothes on your folding speed.
Yes, that's what I would have said as an expert in this area. What are you most excited about, most eager about, and what are you most scared and skeptical of in the next, we'll say, 5 years of Google's immediate future?
I'm most excited about the technologies we're building to market to make the Google user the safest, the Google experience, the safest online experience in the world. If you're using a Google product, safety is your choice. You're not going to be phished. You're not going to be subject to misinformation. You're not going to have your privacy violated. Online safety is something that we all worry about. And I'm very excited about lots of things that are happening at Google today that will solidify what I believe we already are today. We are the safest online experience in the internet. And I'm excited about not only remaining that at that post, at that position, but actually improving it further.
Excellent.
Yeah, and I want to first echo what Louise said. As the parent of two teenage kids, this is something that I'm very concerned over in terms of what's out there. And just broadly speaking, to add to that, I don't know if I can match the gravity of what Louise mentioned, but I think that we are approaching an era where we're going to be able to connect people to real-time insights. In other words, we've gotten to a place where people can interact with computing very effectively. Search is one example. But I think we're going to get to a place in the next few years where you will proactively get the information that you need when you need it. Universal language translation is, I think, the tip of the iceberg. But I think that we are in the era of learning and anticipating as opposed to reacting. And I think that the usefulness gauge and bar for our services is going to go up over the coming years in the safe model that Louise is alluding to.
All right, I want to thank our guests, Luis and Amin, for such an amazing conversation. It's been a terrific season. Thank you so much for listening. Be sure to check out allaboutcircuits.com, where you can listen to all prior episodes and future episodes. And if you enjoy this podcast, please leave us a review on Apple, Google, Spotify, or wherever you listen. Have a great summer.